Hi everyone. So let's say we are given the following circuits and we're needed to find a Thevenin equivalent within terminal AB. And this time we're going to use node analysis. So let's get started. First of all, we're going to name the node. This one is going to be node 1, where the voltage is V1. And this one is going to be node number 2, the voltage V2. And this one is our reference, or node 0, which has V0. We can assign the specific current. The current here, let's call it I1. Here, let's call it I2. And here, let's call it I3. This one is going to be I4. And this one is going to be I5. So from node 1, we will have I1 equals to I2 plus I3. As you can see here, I1 equals to 1 amps. And I2 equals to V1 over 6 plus I3 equals to V1 minus 14 volts minus V2 over 14 amps. If you organize this one, it's going to be 1 amps equals to V1 over 6 plus V1 plus 14 minus V2 over 14. So this is similar to 84 equals to 14 V1 plus 6 V1 plus 84 minus 6 V2, which equals to 20 V1 minus 6 V2 equals to 0, which equals to 10 V1 minus 3 V2 equals to 0. This is equation number 1 that we're going to solve. Then if you go to node 2, we will have I3 equals to I4 plus I5. From node 1, we have I3 as V1 plus 14 minus V2 over 14. So this is going to be equals to I4, which is equal to 3 amps, plus I5, which equals to V2 over 5. So organizing this, we get 5 V1 minus 19 V2 equals to 140. This is equation number 2. So if we solve the two equations, if we take this equation and this equation, from equation 1 we get V1 equals to 3 V2 over 10. So we substitute to this equation, we get 5 3 V2 over 10 minus 19 V2 equals to 140. This one and this one will cancel out, you get 3 V2 over 2 minus 19 V2 equals to 140. So this is similar to 3 V2 minus 38 V2 equals to 280. Add these two together, you get 41. Add these two together, you get minus 35 V2 equals to 280. So V2 equals to minus 8. So if we go back to our circuit diagram here, we can see V2 is similar to VAB, which is Thevenin voltage. So from our diagram, we get the voltage of open circuit, which equals to voltage of AB equals to voltage of Thevenin, which is equals to minus 8 volts. After that, we need to get the Thevenin resistance. Remember that to have Thevenin equivalent, we need Thevenin resistance and Thevenin voltage. So to calculate the Thevenin resistance from our diagram here, we just shut down the independent sources. Independent sources here, the current source, so it's going to be open here. The voltage source is going to be closed here, and this current source is going to be open. The obtained circuit will be like the following. Here we have A, we have B, and we need to calculate this, the total resistance or the equivalent resistance, which is Thevenin resistance. This one is 6 ohm, this one is 14 ohm, and this one is 5 ohm. From the diagram, you can see that the total resistance will be 6 ohm in series with 14 ohm, and all of them in parallel with 5 ohm. So we'll have 6 ohm plus 14 ohm, all of them in parallel with 5 ohm. So this will be the Thevenin resistance of 20 times 5 ohm over 20 plus 5, which is equals to 100 over 25 equals to 4 ohm. So our Thevenin resistance equals to 4 ohm and Thevenin voltage equals to minus. Thevenin equivalent circuit would be here we'll have 4 ohm and here we'll have 8 volts. And why do I put 8 instead of minus 8? It's because the voltage sources here is opposite with the flow of current. So current is flowing from left to right. So this one, it means minus 8 instead of plus 8 volts. So in order to prove what we got from our previous exercise, I've added the simulation. As you can see here, this is our original diagram, circuit diagram. So in resistance 3, in R3, it's where we get our Thevenin voltage between point A and point B. So let's run the simulation and see if we get 8 volts. I'll run the simulation, and if we check here at the multimeter, if we measure voltage from these 2 points, we get minus 8 volts as we obtained it using the previous method. Thanks.